Greetings, math fans. All right, so today we're going to start a new chapter, and this chapter is statistics. Okay, so the first day we're going to talk about some basic things, and every day we're going to kind of continue on. So let's just get started. Basically, for this part of the notes here, we're going to use the given data that I have right here. I'll just highlight this data right here. Okay, and anyway, note that data is in numerical order. Now, I'm not always going to give this to you. In fact, in real life, it's not going to be in numerical order. Okay, you're probably going to put it in a spreadsheet, or you can just type it into some computer software, and it's going to order for you. But right now, we're going to have to order things just in a little bit. All right. So let's talk about the first thing here is the mean. Okay, it's very scary because it's mean. The average, or the arithmetic average of a set of values. Basically, it's what you guys know already, right? You just add all the numbers up and you divide by the number of numbers and you get your total. So there it is, all the data on top there, divided by 11. So 333 divided by 11 is 30.27. That is the mean, okay? The median is the midpoint of the range of numbers that are arranged in the order of value. So in other words, you order all the numbers, and then what you do is you actually find the physical middle of the data. So in this case here, number 34 is the physical middle because there are 5 numbers on either side. Okay, so 34 is the median. If there's an even number of data values, then the median is the mean average of the two middle values. So let's just say, for example, 34 and 35 were the two middle numbers, okay, because we had an even number of numbers. And so 34 and 35 are the two middle numbers. You would say 34 plus 35 divided by 2. You'd take the mean of those two numbers. So your median would actually be 34.5. So there's actually not a piece of data out there, but that is what the median is. All right? That's only if you have an even number of pieces of data where you have two middles, two physical middles. Okay. The mode is the value that occurs most often in a set of data. In this case here, 40, right? 40 occurs twice. Nothing else occurs twice, so that's the mode. If there's more than one mode, then you list all the modes. Pretty easy. And then we call that multimodal. So like 2 modes is bimodal, 3 modes, trimodal, etc. Okay? Pretty straightforward. Okay, a stem and leaf plot is basically, it's a device for presenting numerical data in a graphical format. Basic stem plot consists of 2 columns separated by a vertical line. The left column contains the stems, the right column contains the leaves. A key is usually included, or in our case, it is always included, to define the meaning of stem and leaves. So basically, I have my numbers above, which I don't have them here because I can't fit it on the screen here, but like 12. So there's 12. So the left side is the tens column and the right side is ones column. It could be different as well. Let's say I had hundreds. You could have the stem could be 2-digit number. The leaf could be, 2-digit number. It all depends on how you want to set this up. But basically you have a few stems and a lot more leaves. Okay? And then your key, like it's written out here, key 1/2 means 12. Okay, you just need to talk about what the key means. Because there's no key, I could say, oh, that 1.2 means 1.2, or 1 point and then 1.3. Or I could say 1.2 means 0.12. I mean, you don't know. So that's why you always have to have a key. Please note, math fans, if you do not have a key on your problems, I will take a point off every time you don't have a key. Okay? So make sure, you might want to even write that the key is key. Oh yeah. All right. But again, this is a great way to organize the data because if you don't have it in numerical order, you could just list the stems and then start putting the leaves down there. Just kind of randomly put it down there, and then you can kind of organize it a lot easier. Okay, and it's, of course, it's easier than when you try to find the mode and you try to find the median to have a stem and leaf plot. Okay, a frequency distribution / cumulative distribution, frequency distribution. Basically, frequency distributions are often presented as lists, ordered by quantity showing the number of times each value appears. Cumulative frequency is a running total of the current frequency and all frequencies below it. A tally just helps with the count. There's usually between 4, and this is important, usually between 4 and 10 class intervals. Okay? So please don't give me 3 or 2 or 1. That doesn't make sense to do 1 because that's just one big class interval. And then you want to give more, you really don't want to give more than 10. And what you're doing is you're kind of grouping the data together. So the deal is if you give less than 4, the groups are too big. It's too much stuff in one group. And if you're giving more than 10 groups, there's too many groups to choose from. It's like if I said the height of everybody in our class and I did 50 groups, it's like everybody would be in their own group because it would be so precise. So you want to, if I talk about the height in our class, it would be maybe from 5'2" to 5'6", 5'6" to 5'10", 5'10" to 6'2", 6'2" to 6'6". So you want to have equal class intervals. Like this one's 10 to 19, 20 to 29. Those are equal intervals of 10. All right. The tally is really easy. You just literally put tick marks. That's like the easiest thing in the world. And the frequency is how often does numbers from 10 to 19 occur? Twice. Cumulative frequency is just 2 because you just start out with 2. And then the next class interval is 20 to 29. Tally 2, frequency 2, and then you add 2 more to that. That's how you get to 4. And the next one, 30 to 39, there are 4 of those, 4 tick marks. And then I add 4 to that. And then there are 3 tick marks, so 3 is a frequency, and I add 3 to that, and I get 11. Okay? Another important thing to point out here, math fans, is please, what kids do sometimes is instead of saying 10 to 19, 20 to 29, they go 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Now, the only problem with that is if you get a piece of data that's 20, what do? You're like, I don't know, I put it in the first one or the second one. I don't know. Okay, so that's why you got to make a cutoff someplace. All right, so that's why I did 10 to 19 and then 20 to 29. Okay, so it's, again, there's 10 in each one. If I count my fingers, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, there's 20 numbers there. Okay, I just counted my fingers. I know you couldn't see me. Okay, so let's keep going. A histogram is a graphical display of tabulated frequencies as shown as bars. All right, it's pretty easy. Basically, you just take your tally and your class interval, and you say, oh, gee, between 10 and 20, I've got, or I guess between 10 and 19, I have 2. Between 20 and 29, I've got 2. Between 30 and 39, I've got 4. So it's pretty easy. Just basically show a bar chart, which is what a histogram, in this case, what a histogram is. Okay? Pretty simple. Let's keep going here. Okay, so this is actually a big part of my lesson, is a modified box and whisker plot. It's a convenient way of graphically depicting groups of numerical data through their 5-number summaries. Okay, the 5-number summary is basically the smallest observation. That's the first one. That's the sample minimum. The first quartile, so a quarter of the data, it goes in the next one. The median, which is the middle, physical middle. The upper quartile, which is Q3, that's the next 25%. And then the largest observation, which is the sample maximum. Okay, those are the 5. It's the 5-number summary. Basically the minimum, the maximum, and Q1, Q2, Q3, where Q2 is your median. Okay, a box plot may also indicate which observations, if any, might be considered outliers. The larger the whisker or box section, the larger the range. Please understand, you guys need to highlight that word. Okay, the larger the range. I'm going to highlight it here. Box and whisker plots are all about range. Okay, it really doesn't have anything to do with mean. It's really medians. Okay, median kind of talks about range, like it's between what value and what value. Is really, really important. Range is important for modified box and whisker plot. Okay, so let's just take a look at this one here real quickly. 5-number summary. Okay, the minimum value is 12 for our data that we're using still. We're still using the old data. So here it is. That's where it's at 12. And I put on here minimum value, not always the end of the whisker. We'll talk about that in a little bit. Okay, Q1, that's the first quartile. That's 21 right here. So this is Q1. And again, this is the minimum. Q2, which is the median, is 34. So this is the median, or sometimes we say that as Q2 the quarter 3. Q3 is 40. That's the next quartile. So basically, you have 1/4 of the data here, 1/4 of the data here, 1/4 of the data here, and then this guy right here, maximum value is 41. And again, not always the end of the whisker. That's 1/4 of the value in that little area there. Okay, so that's basically just kind of shows again the range of the median and the quartiles of the data that you're given. Okay. An outlier, none is shown for this example, but data that is past the length of the whisker. And we'll talk about that, how to get that in a little bit. But if data is past the length of the whisker, it's called an outlier. A good example of that, math fans, is you have a whole bunch of cars and they all go 100 miles an hour, 110 miles an hour. They're all just normal cars, right? And then you got a Lamborghini that pulls up. That thing can do 220 miles an hour. That's going to be an outlier because that goes way faster than most of the other cars. All right, so that's an outlier again. It's something that's like way out, way out. You don't really even use data sometimes that's an outlier because it kind of messes up the data. Okay, so and then you have something called an interquartile range, IQR. Okay, the difference between Q1 and Q3 is the interquartile range. So in other words, I found my Q1. Right, Q1 was 21 and Q3 was 40, so I just do 40 minus 21, which is 19. That's my IQR, interquartile range. It's always positive, so don't subtract the wrong one and go Q1 minus Q3 and get a negative 19. All right, that would be a bad thing. Okay, if there are no outliers, what percent of the data is contained between each of the 5 number summaries? Well, we just talked about that. How much is in each of the 5 number summaries? 25%. Very important. Okay? All right, so let's do a little bit more investigation here with modified box and whisker plots, and then we'll actually create one. Okay, so here are more detailed instructions to create it. Number 1, create a stem and leaf plot to order the data. Got to do that. Got to have the data in a good order in order to do a box and whisker plot. The next thing you want to do is you want to find the median. You want to find the physical middle of your data. And then the third step is you want to find quartile 1 and quartile 3. Basically, it's the medians of data above and below the original median. So it's almost like you're taking another set of medians between the median and the lower piece of data and the median and the higher piece of data. Okay? And I even said it can be kind of tricky, so let's take a look at a few scenarios. Okay, so for the first scenario is actually the easiest one. Well, I don't want to say it's the easiest one, but the first scenario is, here, do you guys agree that the median for this one is, the physical middle is 3? Okay, now you're going to move over, basically you're going to cross off the 3, and then you're going to look at these 2 pieces of data, and I'm going to find the median between those. That's Q1. Well, what I tell you, if you have an even number of pieces of data, or if there are 2 middles for a median, you take the average of the 2. So truly, I do 1 plus 2 is 3, 3 divided 2 is 1.5. So that gives us 1.5. Same thing with this next one, 4 and 5, right? That's 2 numbers. So 4 plus 5 is 9, 9 divided by 2, average of those, 4.5. Okay, so that is, that's how you find Q1 and Q3. Very, very important. Let's take a look at scenario 2. Again, my physical middle, because I have 6 numbers, basically a good way to find out the middle of this, math fans, if you have 6 numbers, you divide it by 2. Well, first of all, if I have an even number, I know I'm going to have two middle terms. Okay. So what you do is you do 6 divided by 2, which is 3. So 3 and 4. It's always that number, and then the next one. That's going to be your median. It's the easiest way to do it. So in other words, I've got 6 numbers here. I did this one already. So 6 divided by 2 is 3. So numbers 3 and 4. And then that's why my median is 3.5. It's the average of those 2. Now here's the deal, math fans. If you have 2 numbers, this is really, really important. And I'll talk about the summary down here in a little bit. But if you have 2 numbers that make up the median, you know how I crossed off, like the first scenario I crossed off the 3? You don't cross off the 3 and the 4. What's going on is, the reason I don't do it is I don't want to eliminate a lot of data, because the more data you eliminate, the less accurate your results are. Okay? So if I have 2 numbers, I'm going to keep both of those numbers. If I have only 1 number, I'm going to get rid of it. Just the law of finding your median. So I'm going to keep 3 and 4. And now I'm going to look at, here's the lower part, it's 1, 2, and 3. Well, what's the median of that? Well, isn't it 2? There it is, 2. And I'm going to look at these 3 numbers. What's the median of that? It's 5. There it is. Okay? Scenario 3. So we got 7 pieces of data. So that's actually easy. 7 pieces of data is just going to be basically our fourth the fourth number. Now, how did I get that so easily? Well, you can count, or you can just say 7 plus 1. You always had 1, and then you divide it by 2. So it's the fourth number. Okay, that's the easiest way to do it. So anyway, here it is, 4. That's my median. And then Q1, well, I cross it off now, right? Because there's only one number, and I have these 3 numbers. And the median, of course, that is 2, and there it is. And the median of those is 6, and there it is, 6. Okay, next one. I have 8 pieces of data, so it's basically 8 divided by 2, which is 4. So 4 and 5, that's going to be my middle term. So 1, 2, 3, 4, these are my middle terms. The median is 4.5. And then, again, I don't cross those off. Now I'm going to use 1, 2, 3, and 4, and 5, 6, 7, and 8. And of course, the medians of those 2 and 3, which is 2.5. And the median of these guys, 6 and 7, is 6.5. And that's how you get your median Q1 and Q3. Those are basically the only scenarios that you have. Okay, there's not going to be any other scenarios except those 4. Okay, so real quickly, summary. If the median of one number, which is an odd number of data, or is one number and it's an odd number of data, when finding Q1 and Q3, do not use the original median as a piece of data. Remember, I crossed it off. But if the median is 2 numbers, then the median is 2 of the middle numbers, and then you always include the original data when you're trying to find the Q1 and Q3. Okay, so that's what we did. We, like for even scenario 4 right here, I didn't cross off the 4 and 5. I used it to find my next set of medians. Okay? When finding Q1 and Q3, use the same method as finding the original median. If Q1 is one number and Q3 is another number, or if Q1 is one number and Q3 is one number, then use those values. If Q1 and Q3 are each 2 numbers, then you find the means to determine Q1 and Q3. I mean, that's exactly what I did here, right? Like for scenario 4, Q1 was between 2 and 3, so it's 2.5. And for scenario 3, Q1 was right at 2, so I used the one number. Okay? All right, so, and again, the interquartile range is number 4 now, is Q3 minus Q1. Okay, that's your IQR. Pretty easy. To find the length of the whisker, which is the maximum whisker length, it's 1.5 times IQR. Okay, you got to know that. It's 1.5 times IQR. All right. The end of a whisker is always a data point. I have that underlined and capitalized. It's always a data point. Put a little star or something, blue moon, green clover, whatever you need to do, put it by the word always a data point, because it is. All right. If a data point is past the maximum length of the whisker, then it's considered an outlier and the data point is plotted. Remember, the whisker may not fully extend even with an outlier. Because remember, the whisker is always a data point. Got to remember that. And there may not be any outliers, or there may be several outliers. Okay? All depends. All right, so a couple more notes here. And we're going to get to making one here in a little bit. A modified box and whisker plot differs from a normal box and whisker plot. Basically, a normal box plot's whiskers extend all the way out to the largest and smallest data point, no matter how far they are. Okay, so you don't really have any outliers. You just extend the whisker all the way out to the smallest and all the way out to the largest. But a modified box and whisker plot may not extend that far, just as we learned in step 5. Okay, because you might have outliers. The smallest value for a whisker is 0. You can't really have, it can't be negative. You can't have a negative whisker. Okay. All right, so let's just analyze an example on the right. Just by looking at it, there's no numbers, but one thing is for sure, there are no outliers for this one. Okay. Basically, each quartile has 25% of the data. So 25%, 25, 25, and 25, because there are no outliers. The range of the lower values is larger than the range of the upper values. So think about it. Here, these are the lower values right here. Do you guys agree that the range is a lot bigger? I mean, look at the size of the rectangle versus this rectangle right here. Okay, so remember I talked about modified box and whisker plot, and we're concerned about the range, or with a median, we're concerned about the range. That's where this comes into play. Okay, so the range is a lot bigger in the lower values than the upper values. Okay, so in other words, we could have, maybe we could do the like the age of people in the classroom. Might have some sophomores and juniors in the class. Okay, and maybe we have a lot more sophomores. Okay, but they're all within a couple years, but the range is a lot. Maybe you might have a young sophomore, but all the juniors are exactly 16 to 17 years old. But the sophomores might be maybe 14, 15, and 16, somewhere around there. So the range is a lot bigger. Okay? All right. The median is greater than the mean. So think about that. The median is greater than the mean since the lower half of the data is spread out more. So it brings the mean down. Right? So if you look at all this data over here, the mean is probably going to be somewhere lower here. Right? But the range of data actually extends all the way down to here, so the median actually, the median is going to be higher. Do you guys agree with that? Because this is truly the median right here, isn't it, math fans? Okay, that's the median, but the lower data points actually kind of suck it down a little bit to the lower amounts. Okay, so in this case here, the median is greater than the mean since the lower half of data is spread out more. And that's actually a pretty important word here. It's spread out more. So it brings the mean down. Okay, so that's just some basics with the box and whisker plot. Now we're actually going to create, I have two of these guys to create with you, and then you'll have more problems for your homework. Okay, so let's take a look at our first example here. One thing I want you guys to notice that the data is not ordered here because we're going to do it one time where you guys have to order it just because you get to use your stem and leaf plot to kind of order things. So a good thing to do is to look at the maximum point and look at the minimum point, just data points, see what's going on here. Our minimum value, you can see right here, is 208. In fact, it's twice 208. And then the maximum value is 282 right here. Okay? So you want to get numbers between 208 and 282. What I'm going to do here is we're going to start out with our stem is going to be, how about 20, and then 21 and 22 and 23. There's a 240, and there's no 250s, 260s, 270s, and then there's 280. Now these don't have to be in order. We're going to show one thing, especially when we get to the frequency distribution, that you really need to have everything. You need to have everything inclusive, right? It's got to be, if I'm doing 20, 21, 22, it's got to be 23, 24, 25, 26. You got to work your way up. But for a stem and leaf plot, you don't have to worry about that. Okay, you can create, you can skip around, you can do whatever. Okay, so let's start out here. We got 2, 0, and we got, I'm just going to kind of go fast here because I have all this done. And I don't want to bore you guys, but you guys should be able to do this. And then 21, there's a 212, 215, and another 215. There's a 220 and a 224, and it's 227, 228. And then there's 23, you got 1157. 24 gives you 236. And then there's our 282 is our maximum point. So remember, you need a key. So we're saying, 20/8. I won't give you the word key for a quiz problem. Okay, you guys need to know to make key. But 20/8 is 208. You can give me any one of them as long as you tell me one of them. Give me an idea. Okay. All right. So the mean is literally you add them all up, and there are 17 pieces of data. 17 pieces. Okay. So it's going to be, if I add them up, I get 3904 divided by 17. Which is 229.65. That's our mean. That's easy. Okay, median is the physical middle. Well, remember, it's 17 pieces of data, so remember what you do is you do 17. Since it's an odd number, you're going to only have one middle. So I can do 17 plus 1, which is 18, divided by 2, which is 9. So I want to count the 9th piece of data. Now, having it in order like this is nice because I just count the 9th one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our 9th one is this piece of data right here. It's 228. There we go. 228. Okay. The mode, which one occurs the most often? Well, I have a 208. I have a 215. And I have a 231. So they're all my modes because those they're repeated twice. If there's something repeated 3 times, then that would be the mode. Okay. We have 208, 215, and 231. Okay, pretty easy. All right, 5-number summary. Basically, you're just, and it says be sure to label each part. So don't just list them. You got your minimum value is 208. Let's just figure out what we have here. Our median, we already know that, is 228. And our maximum value is 282. So let's find we need Q1 and we need Q3. So let's find that. Basically, let's go back to our data. Q1 is the middle of the left-hand side. So if I count the number of pieces of data, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 pieces of data to the left of that 8. Because remember, I'm not using the 8 anymore. Okay? So if I have 8 pieces of data, that means I'm using, remember, 8 divided by 2 is 4. So I'm using 4 and 5. The fourth and fifth one. So if I count 1, 2, 3, fourth and fifth one happen to be the same number. So it's the average of those, the mean of 215, 215, which of course is just 215. So that is my Q1 is 215. Let's move this down here a little bit. 215. Okay, and then Q3 is kind of the same thing here. It's the fourth and fifth one in. So 1, 2, 3, fourth and fifth one in. So it's basically 237 plus 242. Right? So 237 plus 242, and it's the mean, the average of those. And that gives me 239.5. Okay, so there we go. We got our minimum, Q1, median, Q2, and Q3, and max. That's our 5-number summary. Very important that you know how to do that. Okay, IQR. Literally, IQR is just Q3 minus Q1. That's all it is, the difference between the quartiles. So it's 239.5 minus 215, which gives us 24.5. Okay? And then the maximum whisker length is basically the IQR times 1.5, which in this case is 1.5 times 24, so 1.5 times 24.5, which is 36.75. That is the maximum whisker length to the left and to the right. So let's look at the left. It's Q1 minus, that's the lower bound. So Q1 minus 36.75, which gives us 178.25. And then the upper bound is Q3 plus 36.75, which gives us 276.25. That's the maximum on the positive side. Okay, so let's create our modified box and whisker plot. What you want to do is you need a number line here. So try to make this nice and straight. If you have a straight edge, it's good. And we've got 180, 190. Got to kind of fit everything in here. This is just what I chose here. But as long as everything fits, make it nice and even and nice and neat. Okay, 230, 240, 250, 260, 270, 280, and 290. It's good. Okay, and it's really easy. Basically, again, let's look at our numbers here. Our Q1 is 215. So I'm going to make this in a little bit different color here. Q1 is 215. So we put a part of the left side of the box. And well, and the median is 228. So we'll go here to 228. It's about there. And our Q3 is 239.5. It's about there. Okay, so this is our box. And it's good to label it. This is Q1. This is the median. Q3. Okay, so we got that. That's pretty easy. Now let's talk about our whisker length. Okay, the whisker down towards the lower part, it goes down to 178.25. Well, what's our lowest piece of data? Isn't it 208? so it goes only to 208. That's our minimum value. Okay? Our maximum value is 276.25. Now our maximum, that's our maximum value for the whisker. Now our maximum value is actually 282. That's called an outlier. So what we're going to do is, you don't make a whisker all the way up to 276. It's got to be a data point. That is so huge, math fans. It's got to be a data point. So what I'm going to do is, if you look at our data, our next lowest data point is you have a 246. Okay, see that? You have a 246. So that's how far, and that's within, so 246. That's definitely less than the maximum whisker, so I really make a whisker at 246. Or the whisker goes up to 246. And then your outlier is at 282, and you plot it. So this is outlier. Okay? And I'm done. That is my modified box and whisker plot. Again, make sure these points right here, the two ends of the whiskers, are data points. They don't just extend all the way out to 276.25. It's got to end at a data point. And then you put your outliers outside of that after that. Okay? Not bad, not bad. So it's kind of a lot of work. We're going to use also our TI-84 as a creative modified box and whisker plot, because I think it's kind of cool showing you guys how to do that. Pretty much the test is going to be by hand, but you know, it's good to know how to do it with your TI-84. Okay, so let's pull up the TI-84 and let's look at some of these directions here. First of all, it says you hit stat 5, so you hit stat 5 is setup editor, and just hit enter. Okay, that resets all your data columns. Let's kind of go back here just to kind of show you a little bit. If I hit stat and then you hit edit. Okay, so you see I have like L1, L2, L3. We're going to type all our data in L1. Now, if I want to clear that, I can go to each one of these and hit delete. See how it deleted it and deleted it. Or I can go to the top. I can hit clear, not delete. Delete means delete the data or delete the column. I want to clear the column. So hit clear, hit enter, and all the numbers are gone. Now let me put some numbers back in here again. Let's say I accidentally go to the top and I hit delete instead. Oh no! L1 is gone. Oh, it's brutal. Okay, well, it's not really gone. What we're going to do is we're going to go back to our setup editor, so we're going to hit stat 5, enter. And then if I go stat edit, column's back. Okay, it's kind of nice. So again, you want to clear the column, you go and hit clear at the top. If you want to delete each individual piece of data, you go to the piece of data and hit delete. But if I hit clear on top, enter, all the data is gone. Okay? All right, so what I want to do is I want to type in all my data now into L1. And it doesn't have to be in any order. That's kind of the beauty of it. So let's go ahead and do that. I already have an order for my stem leaf plot, so I'll just kind of go based off of that. 208. Okay, so I kind of fast forward here because it takes me a little bit longer to type it in on my computer here. But you should basically have all the data. You can see after I hit enter, I had L1 of 18. So I know I have 17 pieces of data, which is a good way to check it, right? All right, so I got all the data in here. The next thing I want to do is I want to turn on my stat plot. So I hit second, stat plot. Okay, and see the one there? We're going to hit enter for 1, or you can just choose 1. And then we're going to turn it on. So it's flashing, we're going to choose on. And then you're going to cursor down, and you're going to choose, you got a cursor to the right. You can't actually go down, but you're going to choose this one right now that's highlighted. Okay, and what that means is you can kind of see it. It's a box and whisker plot modified. Those two little dots to the right, that means you have outliers. As opposed to the one on the right, that is a regular box and whisker plot because it has no outliers. It extends all the way out to all the data points. Okay, everything else should be the same as what I have here. X list is L1, frequency is 1, and then the mark is, I just chose the square. You can use a plus or dot. It doesn't really matter. Okay, so once you have all that in there, now you're going to hit zoom. So zoom. And we're going to do stat 9. So let me just cursor down and show you what do we have here. Okay, so there's zoom 9, is zoom stat. And there you go. Oh yeah, right? If you take a look at our box and whisker plot that we made, it's kind of cool. There it is. There's the outlier. So that makes our box and whisker plot. So now what I can do is hit trace, which is kind of cool too. So if you hit trace, so the minimum is 208. There's our minimum 208. And then I just cursor over. Q1, 215, there it is. There's our median, 228. Cursor over again. There's Q3, 239.5. Cursor over again, 246, that's the end of our whisker. And then last one is our maximum point. Okay, it's kind of cool. So your calculator does a box and whisker plot all by itself. All right, but of course you have to know how to do it manually. All right, let's do one more manually. And should be pretty mellow. Okay. Notice this data is all in order. Okay. Again, I'm not trying to waste your time and have you guys put it in order because I don't want to mess you guys up with that. So most of the time I'm going to give you things in order, but just kind of be aware if it's in order or not in order. All right. So let's kind of fill some of this in. And I'm going to fill it in kind of quickly here. So we have our stem is going to be 3, 5, 6, 7, 8, 9, 10, and 13. Those are our stems. And our leaves are going to be 5, 2, 0, and 5, 0, 3, 5, 4, 6, 7, 7, 8, 8, 9, and then 1, 3, 3 5s, and a 1. And then the 10 is going to be 1, 5, 8, 9, and the 1, 3 is going to be with a 0. Okay? So that's all in order. Got to make our key. So we're going to say, oh, well, 3, 5 means 35. Okay? So I'm going to add all those up. And if I add all these up, I get 2158. And there are 25 pieces of data, so you can divide by 25. And that gives me 86.32. That's my mean. Okay, the median, since there are 25 pieces of data, I'm going to say 25 plus 1 is 26, divided by 2 is 13. So I'm going to pick the 13th piece of data here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is right here. Okay, and again, it's only one median, which is nice, so it means I cross it off when I use it, but the median is 88. And the mode is which one occurs most often. 95 occurs 3 times, so the mode is 95. Okay, pretty easy. Okay, let's make a frequency distribution chart. Again, it should be between 4 and 10 equal intervals. So, you know, you don't want to go by tens necessarily because that's going to be kind of stretching it, right? You're going to have 30s, 40s, 50s, all the way to 130s. That's kind of stretching it. So I did it by 20. Now yours might be a little bit different, and that's fine. I'm not really picky about it as long as they're equal intervals. Okay, and they're between 4 and 10. So this is what I chose. I said between 31 and 50, between 51 and 70, between 71 and 90, between 91 and 110, and between 111 and 130. Okay? And, if I tally these up, can't really fit everything on the screen, but that's okay. If I tally these up, I would get 1 of those, 4 of those, 9 of those, 10 of those and 1 of those. So the frequency, just add up the tallies, is 1, 4, 9, 10, 1. Cumulative frequency, really easy. It's 1, 1 plus 4 is 5, plus 9, 14, plus 10, 24, and plus 1 is 25. Okay, number of pieces of data. Okay, it's pretty easy. Let's make a histogram. So basically, we start from 31 to 50, and remember, you've probably seen this before. If you don't start with, as opposed to extending that, I'll get to make it to 30 to start, we can just do this, right? So we'll say this is going to be 30 and 50, 70, 90, 110, and 130. Okay? And this is going to be 1 and 2, 3 and 4, 5, 6, 7, 8, 9, 10. Okay, so for 31 to 50, you only had 1 of those. And from 51 to 70, you had 4. So we're going to go up to 4 here. Try to be a little neat, be nice. 71 to 90, you have 9. So we're going to go up to 9. And then from 91 to 110, you're going to have 10. And then from 110 to 130, you're going back down to 1. Okay? And if you want to decorate these nicely, it's very nice. Okay? So whatever you want. Okay. But anyway, that is a histogram. All right, so let's go back to the 5-number summary now. We already know our minimum value is 35, so don't forget to label them. Our median was 88. We already figured that out. Our maximum value was 135. That's pretty easy. Now let's go back to the data here. We got to figure out Q1 and Q3. So let's go back here. Okay, so if I count the number of pieces of data, first of all, it's that was the number 8 was the center, right? And I don't use it anymore because there's only 1 piece of data, so I cross it off. That means this is our 25 pieces of data, and I took 1 off. That's 24. That means there's 12 on each side. So if there's 12 on each side, do you guys agree? 12 divided by 2 is 6. So I'm looking at 6 and 7. Okay. So 1, 2, 3, 4, 5, 6, and 7 are these 2 numbers here. So basically it's 73 plus 75 over 2, which is 74. That's my Q1. Okay, let's do the other one is again 6 and 7. So 1, 2, 3, 4, 5, 6, and 7 are these 2. So 90. Okay, this actually should be a 7 here. Okay, it's 97. But anyway, the average of those 2, let's go back down here a little bit, is going to be 95 plus 97 divided by 2, which gives me 96. Okay, so that is Q2, or Q3, sorry. Okay, so let's put that down here. Q1 is 74, and Q3 is 96. Okay, pretty easy. Let's go and figure out interquartile range. Remember, it's Q3 minus Q1, so it's 96 minus 74, which is 22. And the maximum whisker length is 22 times 1.5, which gives me 33. So what we're going to do is I'm going to do Q1 minus 33, which is 74 minus 33, or 41, and Q1 or Q3 plus 33, which is 96 plus 33, which is 129. So again, this is maximum length. Max length. Okay? So let us make our graph now. I need to go from basically 30 to 130. So 30, and we can go up by tens. 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, and 140. Okay? You know, and again, I don't want you guys to crunch all this stuff. Sometimes I get kids that make this really tiny box and whisker plot. It's like, I can't even read it. You got to spread out. Make your data big numbers. You know, I want to see a big number line taking up the whole length of the page, the width of the page. All right? Okay, so our Q1 is 74. So we're going to put it there. Our median is 88. Our Q3 is 96. Put there. So we can draw a box and label it Q1, median, Q3, and our maximum whisker length, it goes down to 41. Okay, but our minimum is 35. And what's the next minimum? You guys agree the next minimum is 52? So we're actually going to go to 52. Remember that whisker, end of whisker's got to be a data point. So 52 is the lowest end of that, and then you have a minimum value, which is 35, which is an outlier. Okay? And going the other way, our maximum length is 129, and if you look, you have 109 is the biggest number, right? Without going over. Because I have 130, but 130 doesn't work. Doesn't quite cut it. So that makes it to 109, and then you plot 130, and this is an outlier. Please label it as an outlier. Okay, so this last part here, math fans, is I want to talk a little bit about some of the different scenarios for modified box and whisker plots. Okay, we already did on page 3. We talked a little bit about one scenario about the mean versus the median. But I just want to kind of cover a few more. I want to talk about whisker lengths and you know what that means. So when we're talking about a modified box and whisker plot, the key word for that is the word range. It is such a key word, okay? Because you know the median here, right? There's 1/4 of the data here, 1/4 of the data in the whiskers, and again, this is kind of assuming there are no outliers. 1/4 is here and 1/4 is here, so you have a total of of all the data, right? 4/4. And you have to, you're looking at the range. And so the first question I have here says, which is greater, the mean or the median? Well, again, half the data is to the left of the median, half the data is to the right of the median. But what happens is because the range of this is so big, of basically Q3, and I don't want to use technical terms when you're describing it, because when you're trying to describe it to the normal person, they're not going to know what Q1, Q2, Q3, they're not going to know any of that, what that means. But basically, right after the mean, that big area right there, or after the median, the range is really big. Okay, so what that does is you have a lot of numbers that are, a big range, like they're way up here, and what that does is that actually pulls the mean higher. So basically, to answer the question, which is greater, it's definitely the mean, and basically the range. Again, I'm using this word, key word. The range of the data is greater above the median, which pulls the mean higher. Okay. So that's basically, when you're talking about modified box and whisker plots, you're always using the word range. A common mistake what kids do is they say, more data is to the right of the median. That's why it pulls the mean higher. And that's not true. There's no more data to the right of the median. There's half the data to the right of the median. It's just that the range of the data is actually spread out, and it's bigger, it's higher. Okay, so don't tell me there's more data, because there isn't. Half the data is to the left of the median, half the data is to the right of the median. And the next question here says, why are the whiskers so short? Well, remember, the whiskers are basically the beginning of the data and the end of the data. And you could say that the range of the lowest, so the range of the lowest and highest data points is very narrow. Okay, so you remember the whisker has to stop at a data point. That means it's stopping. If you're looking at, let's say, this left data point, it's got to stop at a data point. If this has no outliers, that means that is truly the lowest data point. Same with the upper data point, right? They're really, really close to the start of the box. So that's why those whiskers are short, because that range is actually very, very narrow. Okay, let's take a look at number 4, just a different modified box and whisker plot here. You can notice that the median looks like it's in the middle of the box, and then you have the left whisker is really big and the right whisker is really small. So again, I asked you the question, which is greater, the mean or the median? Now some of you would look at it and go, oh well, Mr. Crevice, the mean and the median are pretty much the same, because look at that it's right in the middle of the box. But yeah, that's great that it's in the middle of the box, but what does that whisker do? That range of that whisker actually pulls all the data, right? It pulls all the data to the left. You know, the mean, it pulls it. If I take the average, the numerical average, the mean, it pulls it all to the left because of that big whisker, and I have that little short whisker out of the right. It doesn't really do too much to pull it to the right. So I would say that the median is greater, and because the range, oh look, I'm using that word range again. The range of the lowest data point is large. I should say data points is large. And those low data points bring down the mean. Again, please don't tell me, oh yeah, there's more data to the left over there. No, that whisker does not mean there's more data. There is 25% of the data is in that whisker. There's 25% of the data in the upper whisker, and there's 25% of the data in each of those boxes, right? So don't use there's more data. That would be totally incorrect to do that. Okay, and then the second part of this, why is the left whisker so long? Well, again, it has such, second right here, it has such a wide range of data points that are low. Okay, as opposed to the upper whisker, or the right whisker, that all that data is all clumped together. I mean, a good example could be, you know, like if I gave an A, right, an A, let's say that whisker is the A pluses, and well, isn't there a short range for A pluses, right? Like 99 and 100%, that's an A plus. So that's why that range is so small. But that whisker could be the Fs. It could be from, you know, getting from 20% to 59% are Fs. So that's why that whisker is really, really, really long. Just a good real life example. All right. Okay, so let's go down here. A couple more. Number 5 says, give a real life example when a histogram would be better for summarizing data than a modified box and whisker plot. So think about a histogram actually shows frequency, right? And a modified box and whisker plot kind of shows like groups, right? It shows ranges. That's kind of the best word for that. So frequency is histogram, ranges is modified box and whisker plot. So when a histogram would be better, it could be, I'm just going to write here any example that shows frequency. That would be where it's a histogram would be better. So you could say like number of A's through F's, right? You could show A's, B's, C's, D's, and F's, and you could have like a nice histogram. Look at the bars and see exactly how many people got what grade. You could do, here's another example. It could be age ranges that speed in a car. Right? Maybe younger people speed more, so you could have like 16 to 20, and different range. You can look at the bar chart, and you can see as the person gets older, 70 to 75, 76 to 80. Right? As they get older, maybe that goes down. So you could definitely, that would be a good example where again you're showing frequency. Number 6, it says give an example, a real life example when a modified box and whisker plot would be better for summarizing data rather than a histogram. So remember I said the box and whisker plot, you're looking at ranges. So if you have a whole bunch of data and you're looking at specific ranges, that's where it would come in handy, as opposed to if you're breaking it up into groups. So I could say something like scores on a test. And maybe instead of actual A's, B's, and C's like I talked about number 5, maybe I'm looking at percentage. Okay, you could also look at like IQs. Right? If I asked you to plot each individual IQ, you'd have a ton of different IQs in there, and would that really show? It doesn't really show frequency, because maybe you get one person that gets this one. There's like one of every different IQ, and that's just going to show a flat line histogram. It's like, well, what does that really show? So basically, there would be too many different data points with a. If you're showing a histogram, there are too many data points, and you're trying to show individual data points, that would not be good. So scores on test, IQs, if you're concerned with, so basically if you're concerned with like the mean of something, mean or median, right? Remember, mean is your average. You add the numbers up and you divide. You definitely want something with the box and whisker plot. With a histogram, it doesn't really show too much about median and really in mean. So anyway, that would be probably the best thing. Like scores on tests or individual IQ numbers would be best for a modified box and whisker plot. Okay, so remember histogram. Just to summarize really quickly, histogram. We're talking about frequency. Box and whisker plot. We're talking about range. It's pretty important. Okay. All right, so anyway, that's it, math fans. It's kind of a long lesson, but it definitely covers everything of this chapter. That's why we're actually spending 2 days on this note sheet, and just to kind of cover every little piece of that. But make sure you guys are good with the details, because the quiz in here, or the test actually, is going to cover all the little details. And make sure you're good to go, and you practice and you read all the notes about everything about the different types of mean, median, mode, frequency, all that stuff. Okay? That's it, math fans. Have an outstanding day. Adios. Goodbye.